All right, today we are going to be reviewing unit number one. So I spent some time and made this two-page review sheet, which kind of condenses everything on how to summarize, analyze data into 2 pages. So it's a quick way for you to review everything. So if you want, you can use this as a review sheet or just go back and listen to this video as I go through it. So I'm just going to walk through each part of the sheet and explain each little section in more detail. So remember unit number one, which is basically how to explore and summarize data. We had two different types of data that we dealt with, which we've talked about since then, this for the entire school year. We have categorical data, which is where you're recording data where people get put into one or multiple categories. For example, are you wearing a red shirt? Yes or no. That's not, you're not given a number response. There's in a category or not. So that's categorical data. And then we have quantitative data, which is your response is a number. So what's your height? 63 inches. What's your weight? 150 pounds. So those would be quantitative data because of you're given a response as a number as opposed to the categorical data. So we have different types of graphs that summarize categorical data and quantitative data. So we're going to start off with categorical data. So most of the data that you're going to be dealing with is quantitative. So there's a lot more options for the quantitative graphs. But we do have some ways that we can display categorical data. The first one is a pie chart. See listed right here, or also called a pie graph. So essentially that is where you split up all the different types of categories into little slices of the pie, and it's a way to visually see what percent is in each one. So just some important things to know about that. Make sure you're including title, you're including labels, and then you're accurately making your proportions right, your slices right in your pie chart, pie graph. Then also another way to display that categorical data is a bar graph or bar chart, which is this right here. Essentially the same thing, except you just have the different proportions, percentages listed as bars. And as you see, the labels are going to be your different groups. So in this example, I put the grades for different classes. So you have 1A, 2A, 3, and 4, the different groups. And then that's how you would display their different percentages. Okay, so those are two different ways you can display categorical data. Then if you have two different types of categorical data, two different variables that you want to display, you can use a segmented bar graph. So like it says here, this is a way to display two different categorical variables. You want to summarize it by splitting the bars into segments. So let's look at this example. So we have males and females. So that's our first variable. And then our second variable is going to be whether they're the percentages within those groups that are juniors and seniors. So you can see for the males, probably about 25% juniors, 75% seniors. And for the females, looks like about 67% juniors and 33% seniors, roughly. Okay, so that's a way that you can break it two different variables down in one graph. Another way is you can see a small graph down here is a side-by-side graph where you can compare them right next to each other. So the important thing about these segmented bar graph or side-by-side is that you include a key so we know what each different shading of the graph represents. And for all these categorical graphs, in general, you want to make sure you're including a title. You want to make sure you're including your labels. I didn't include it all in here just so I could fit it all on one sheet, but make sure you have titles and labels for all your different graphs and make sure that they're spaced evenly and that if it's like a pie chart, you have your proportions graphed in an accurate manner. So that's pretty much it for the categorical data. We're going to spend the rest of the video talking about quantitative data. So first thing we're going to talk about is how to describe it. And remember, this is where we use our SOX acronym to describe this quantitative data. So remember, the S part of SOX represents talking about the shape. So a couple different things we can talk about when we're talking about the shape. We can talk about how many peaks the graph has. So if I have a unimodal graph, that's going to have one peak like this. If it was bimodal, I have two peaks like this. And then if it was trimodal or quadmodal, you just change the prefix. That's how many peaks it has. So if it was trimodal, you would have 3 different peaks. Okay, so that's the first part. But then the thing that's really important that you want to talk about with this shape is whether it's skewed or symmetric. So remember, if it is skewed to the left, we have this tail going off to the left. That's a way to remember which direction it's going to be skewed. If it's symmetric, it looks symmetrical. And then if it's skewed to the right, you're going to have a tail going off to the right side. Okay, another way that we can say that for skewed to the left, we say skewed to the lower values, and then skewed to the right would be skewed to the higher values. So that's the first thing you want to talk about when you're analyzing your quantitative graphs is the shape. Then we can also talk about the outliers. So if there just appears to be any outliers, for most problems, you just need to say if there appears to be any outliers. So if there's a couple different points that look like they're either way higher or way lower than the other points, you can say they're possible outliers. If the question specifically asking you to calculate an outlier, remember we have a formula to do that, which is you take Q1 minus the interquartile range times 1.5, and anything below that number is going to give you, is going to be an outlier. And then we kind of do the inverse of that. We take Q3 plus the interquartile range times 1.5. Anything above that value is going to be an outlier. So that's the actual calculation that we do to figure out outliers. But if it doesn't ask you to actually calculate those out specifically, in your paragraph response, you can say they're potential outliers. All right, so we just dealt with the SO of SOX. Now we're going to go on to the C, which deals with center. So if we're dealing with center, that describes essentially the central part of the graph. But when we're using this, we want to use 2 different forms of measurement, the mean or the median. Now remember, the mean is influenced by outliers because we add up all those data points and divide by the number of data points. So if we have a really high outlier, then that's going to drag our mean higher, and it's going to influence our central point of measurement. Okay, but since the median is just the middle points, if we have a really, really high point, that's not going to influence our median, as opposed to if the highest point was just 1 or 2 above the next highest point. So we say that the mean is influenced by outliers, and our median is resistant to outliers. So when you're talking about center, you want to use one of those 2 different measurements to give a nice quantitative summary stats to describe where the center is. Then for spread, you want to describe the spread by using a measurement of spread. So you can talk about what the standard deviation is, the interquartile range, or the regular range. Remember, regular range is just the maximum value minus the minimum value. Depending on what information is given to you in the problem, depending on what graph you're dealing with, that's going to determine what form of spread you want to use. Or if it's you're comparing two or more different types of graphs together in your summary paragraph, you can just talk about the variability. So remember, variability is how spread apart or condensed the graphs are. So if I had, let's say, I'm going to make a just like a dot plot, or I'll make it to the curve right here. So let's say I had a curve like this, then another curve like that. I would say this curve has low variability because it's skinny, condensed together, close together. So all of our answers are close together, so there's not a lot of variability in our answers. So we say low variability. If we had a curve like this that we're comparing it against, that's a lot more spread out, so we'd have more variability. So we say that this curve up here has lower variability than this one. Or the opposite, this one has more variability than this curve. All right, so just make sure that you're including one of those. And again, you're just going to have to look at the problem, the graph, in context, determine which would be the most appropriate measurement to include for your spread. Now, when you're writing a response, you want to make sure that you're including the 3 C's. So remember the 3 C's listed right here. This is just a way to kind of check to make sure that you're tying your paragraph together in an effective manner. So you want to make sure you're using complete sentences, pretty self-explanatory. You want to make sure it's concise. Okay, this is a real world thing that everybody, no matter what your job is, if you're doing any type of writing, that you're going to have to do is how to make concise writing. Whether your job is to post on social media, you're trying to condense what you're trying to say so you don't have some super long post that people aren't going to read. So the same thing where if you're dealing with stats, we're trying to make concise responses so we get all the information we need across in the lowest amount of space so we don't lose people's attention or confuse people. Then we also want to make sure that we're including in context with the problem. This is so important. You can't just go through and say what the mean is, the median is, the interquartile range, just list off all these summary stats and not include what you're talking about in context. So a way to think about it is if you take your paragraph describing your graph and give that to somebody that hasn't seen the graph before. Let's say Ms. Sanchez walks in the class and you just give her your summary paragraph. She should be able to read through the paragraph and understand what your data is talking about because you're talking about it in context with the problem. But if you just list off a bunch of summary stats without context, she won't know what your data is referring to. So make sure that you're including context. I'm going to talk about that a little bit more later on in the video. So then we're going to move on to all the different types of quantitative graphs that we can deal with. So first one's dot plot. That's probably the most simple graph to use where you're putting dots on the one axis. So make sure that you're including your title. Make sure your x-axis is labeled. Again, I include that just so I could fit it all on 2 pages. The thing about the dot plot is it doesn't have to start at 0, so you can just start it with the lowest possible value, so you don't have all this blank space off to the left of the graph. Make sure that your notches are evenly spaced, and that's pretty much it for dot plots. A stem plot and back-to-back stem plot, a couple things. You want to make sure that your rows line up vertically, okay? So you can see on these, my numbers line up vertically, because if you don't line them up vertically, then that's going to skew how you perceive the shape of the graph, okay? Because if you have one row condensed together and the other one spread apart, it's going to skew what you perceive the peaks to be. You also want to make sure that you're including the spacing on this part, the stem, evenly as well, because that's going to make the way you perceive the skewness, the shape of the graph, whether symmetric or skewed, is going to change that if it's not skewed. So you want to make sure that you have all those evenly spaced. Another thing that's really important that they will take off points on the AP test for if you don't include is a key. So make sure you're including your key for your back-to-back stem plot. Something else I did not write down, but it's important to know, is that if it's a right side of the graph for the back-to-back stem plot, you're going to write your numbers in order from lowest to highest, and then from the left is going to be the opposite of that. So a way to think about it is the lowest numbers always start closest to the stem, and then you work your way out past that. All right. So that is the stem plot and the back-to-back stem plot. Moving on, we have our histogram, which is basically you create these different bins, which create bars. They give you the shape of the graph. Okay, now it's just important to know that depending on the width of the graph, is going to determine how many data points fit in within that bin, and it will determine the shape. Because technically you could have like one big bin, and then just going to be one graph that comes up. But if you make smaller bins, it's usually going to make the shape a little bit more accurate and easier to see. The box plot is next. This is one that comes up a lot, so make sure you're paying attention to this next part and know all the different parts. So remember, the box plot, this kind of corresponds with our median and interquartile range. So the minimum value is always going to be the lowest point on your dot plot. Your maximum value is going to be your highest point on your dot plot. Then the left side of the box, right here, that's going to be Q1. The line inside the box is going to be your median. The right side of the box is going to be Q3. And then if you have points detached from the whisker right here, those are going to be outliers. So they could be circles, they could be stars, they could be plus signs. Those are going to be calculated outliers. So if this was a graph that they gave you on the AP test, and you saw those symbols, those are actual outliers that they did the formula for and are official outliers. All right, so some other formulas to know. Remember, interquartile range is Q3 minus Q1. The way that looks on the graph is the interquartile range is the width of the box. The variance is going to be your standard deviation squared. And then the mean is, again, this is another thing I put here twice just because it's really important because they test it a lot. So the mean is influenced by outliers. And the median is resistant to that. All right, so make sure that you make note of that. And then we're just going to end with some paragraph tips, basically how to tie everything together again, just because it's so important that you're making these paragraphs nice and easy to read. Because when they're grading your test, you're going to be teachers over the summer in a large conference room that are reading the same question 8 hours a day for the entire week. So you want to make sure everything's really easy for them to read through. You get all your points nice and quickly. If you follow this kind of template, that's what they're going to be looking for. So first, you want your first sentence to just be a general interpretation of your results. Okay? So whatever that means, a lot of different, whatever the situation is, just basically if you had to describe it to, I don't know, if you had like a younger brother or sister, if you had to describe it, that should be your first sentence. Then, the middle sentences of the paragraph should be backing up your claim that you made at the top of the paragraph using SOCS. So make sure you're talking about the spread, outliers, center, and spread. And then third, end with a conclusion sentence in context with the problem. So again, just kind of tying in, summarizing everything that you found with your analyst and using SOCS. And yeah, that's pretty much it as what you want to include in your paragraph. So again, you want to be concise and also write legibly so it's easy to read. Again, especially being able to write and analyze this is something that's super important, It's going to be a really good, useful tool in college and when you get into the workplace because, like I said, a lot of people do not know how to understand graphs. So if you can understand graphs and then write a paragraph that is able to summarize it and explain it to somebody who doesn't know how to read graphs, then that's going to give you a really marketable skill when you enter the workforce. Okay, so again, this is basically just a review sheet that you can use as we're reviewing all the different parts. So you can use it today, and as you're studying for the AP test, anything that comes back from Unit 1, I would take out this review sheet and very useful information on this. So make sure you got everything on the sheet memorized before the test.